Okay, Pythagoras' theorem is a rule, a very famous mathematical rule, that links the sides of a right-angled triangle. Now, the way that you may have been taught to remember this is by chanting the formula a squared equals b squared plus c squared, which is all well and good, but it only works if you write the a, b and c in the right places on your right-angled triangle. And it has to be that the a is the longest side in the right-angled triangle, which is called the hypotenuse, and the b and the c are the other two. Okay, if you can remember that, then the rule is a squared equals b squared plus c squared. But if you've got your a in the wrong place, that's going to break down horribly. So when we look at these questions, I'm going to show you another way of remembering it. So as I mentioned, this only works in right-angled triangles. So you will see when you come across this question, which will be at the very far end of an exam paper, that it's pretty obvious by the box there that we're talking about a right-angled triangle. The first thing to do is to square your sides. So you've got your 3.6 and you've got your 7.3. So 3.6 squared is 12.96. And your 7.3 squared, remember you're not doubling here, you're squaring, is 53.29. So whatever you're given, you're going to square them. Then let's take a look at what we're trying to do here. We're trying to find the length of AC. If AC, or if the side you're trying to find is the longest side, you're going to add your squares together. If it's a shorter side, you're going to take them away. That's what you need to remember. Forget the a squared's b squared, c squared's nonsense. What are you trying to find? Is it the longest side? Yep, you're going to add them. Is it the shorter side? Nope, you're going to add them. Is it the shorter side? Yep, you're going to take them away. Right, in this case, the length of AC, you can see from the diagram, is the longest side. So what you're going to do is AC squared is those two added up. 12.96 and 53.29. 66.25. Now, at the moment there, we're working with all the squares. We don't want the squares, we just want AC on its own. So we have to do the opposite of squaring. The opposite of squaring on your calculator is the square root button, which is what my pen is just pointing at there. So in order to work out AC, we're going to do the square root of 66.25. So on your calculator, there's your square root button, and if you just press ans, that's going to plonk into there the 66.25 that was already on your calculator screen. So that's going to be 8.1 centimeter. Alright, so remember that with all of these now, we're going to square the sides we're given, then we have to decide, am I going to add them or subtract them? If it's the longest side I'm trying to find, we're adding, otherwise we're subtracting. Right, so here we go again then. Two sides, it's a right angle triangle, I'm going to square them. So 9.6 squared is off the page, bring it back in, 92.16, 7.2 squared is 51.84. I want to find y. Is y the longest side? Yes, it is. So I'm going to add those two together. 92.16 plus 51.84 144. I was working with squares up there. I don't want to be working with squares. I've got to undo it, which is square rooting it. And I know anyway that the square root of 144 is 12 centimeters. Here we go again. Right angle triangle. Square, square. $53.29. $23.04. What am I trying to find? I'm trying to find XZ. Is it the longest side? No, it's not. So I'm not adding, I'm subtracting. And when you're subtracting, you don't want a negative answer. So you're always going to be taking the smaller number away from the bigger number. Remember, I'm working with squares, so it's xz squared. So 53.29 take 23.04, 30.25. Get rid of the square. I've got the square root, my answer. So square root of 32.5, square root my answer, 5.5, and the units this time will be meters. Okay, this time they're disguising my triangle. A ladder which is 7.6 meters long is placed against a vertical wall. The foot of the ladder rests on a horizontal floor and is 2.4 meters away from the bottom of the wall. Calculate how far the top of the ladder is above the floor. Well, if I've got vertical and horizontal, that means I've got a right angle. That should ring the bell for Pythagoras in your brain. And we do the squares. 7.6 squared, 57.76. Not getting much light today. No. 57.76. 2.4 squared, 5.76. Now ask yourself the question, are you trying to find the longest side? No, you're not, so you're going to be subtracting. So what we want here is this here, which I'll call h for height. So I want to find h squared, which is going to be a subtraction. So h squared is 57.76, take 5.76, 52. I don't want h squared, I want h, so I have to undo all my squares by square rooting 52, square root ans, which is 7.2 meters. So exactly the same method every time. Square the sides you're given, then make the decision, am I adding them or subtracting them? Then square root your answer, and then you're done. Here we go again. Question 5. Slightly disguised, one end of a piece of rope, 8.4 meters long, is tied to the top of a vertical pole XY. The other end is tied to the ground at the point Z, which is at a horizontal distance of 6.6 meters from the foot of the pole. Calculate the height. So I want this distance here. Whoop, I got my right angle. I'm into Pythag. Square 8.4, 70.56. Square 6.6, 43.56. So h squared, is it the longest side? No, it's not, so I'm subtracting. So h squared will be 70.56 take 43.56, which is 27. I don't want h squared. I've finished with the squares. I've got to square root. So the square root of 27 is 5.2, because the next number along is 5 or more, so that rounds up to 5.2 meters. Now this one they've shoved in a circle, but it doesn't make any difference. It's still a right angle triangle, and we want to find AC. So it's Pythag. We square 8.7 squared 75.69. 5.4 squared 29.16. Is it the longest side we're trying to find? No, we know the longest side. If the triangle is such that you're not really sure, the longest side always is opposite the right angle. So that's the longest side. That's the longest side. Okay? The little box points to the longest side. So I know the longest side, so AC I need to subtract. We're working with squares. So AC squared 75.69 take 29.16. 75.69 take 29.16. 46.53. I don't want squares. I got to get rid of my square. I got to undo it by square rooting. Square root ants 6.8 centimeters. And then to finish off, two slightly different questions. First question is about as tough as you're going to get on a calculator paper 2 on the foundation tier. Okay, it ties in the Prism questions that I did in another section. I just call that little bit back. Okay, volume of a prism, area of cross section times the length. The cross section is what you get when you take a three-dimensional shape and slice it. The area that the knife is cutting through is the cross section. So here the cross section is this. It's the triangular face. Okay, if I was cutting that shape with a saw or with a knife, that would be the face that would be produced by the knife cut. In order to work out the volume of this shape, I need to work out the area of that cross section. In order to work out the area of that cross section, it's a triangle, it's going to be half times base times height. I don't know the height. It's a right angle triangle, so I have to use Pythagoras to find that before I can work out the area, before I can work out the volume. Okay, so this is really challenging stuff here. So let's get the Pythagoras bit done first of all. Okay, I've got that all in orange there now, but I'm going to square that. So I've got my 5.3 squared, 28.09. I'm going to square this, 2.8 squared, 7.84. I want AB. Is it the longest side? No, it's not. So I got to subtract. I'm working with squares at the moment, so it's AB squared. 28.09 take 7.84. AB squared 28.09 take 7.84. 20.25. I don't want the square, so I have to undo it. Square root ans 4.5. Okay, so I know now that that distance is 4.5 centimeters. So the area of the triangle is half times base 2.8 times height, which is 4.5. So on my calculator, half times 2.8 times 4.5, 6.3. That's area, so that's centimeters squared. So the volume, if I just go back to the formula from the front, is going to be the area of the cross section times the length. Well, I've now worked out the area of the cross section is that, so the volume will be 6.3 times the length of this prism, which is 3.5. So finishing off on my calculator, times 3.5, 22.05, and the units, remember, for volume would be centimeters cubed. Now that is a really challenging question on a foundation tier paper. If you can follow what I've done there, and if you can do that yourself, then you're going to have absolutely no problem whatsoever getting a grade C in the final exam. Alright, the last question, which again is a little bit different again, because in this question it doesn't tell you that that's a right angle triangle. In fact, the question is saying, can you show it is a right angle triangle? Well, if it is a right angle triangle, our squares, 6 squared is 36, 8 squared is 64, 10 squared is 100. If the two smaller sides add up to the bigger side, it's a right angle, because then Pythagoras' rule works. So 100 equals 36 plus 64. Yes, it does. So just by showing that, Pythagoras rule or theorem applies. So it is a right angled triangle. Okay? If you squared those and you couldn't make two of them add up to the other one, then it wouldn't be a right angled triangle. And again, I've only seen a question like that once. Nevertheless, see if you can get your head around it.